In this video, we will use factorial and double factorial to generate the Taylor-Maclaurin series sum of the Gauss negative x function. We begin with the Taylor-Maclaurin series sum expansion, which is the summation of a times x to the power 2n plus 1, where the value of a can be a1 or a2. a1 if it is factorial, a2 if you're using double factorial. And the value of n will be from 0 to infinity. In this case, we can go as far as 16, which is good enough. And we continue. This will be our formula, minus 1 raised to the power n plus 1. So this is the value of n plus 1. And we'll copy the value of n because we're using that very often. And the second part, times 2 raised to the power n. And then finally, third part, that is double factorial 2n. So factorial double factorial of 2 times n minus 1 all over. This one is factorial 2n plus 1. So factorial 2 times n plus 1 plus 1 and enter. So we have an error here. We'll find out what value this is. We'll check with the factorial. So this is equal to array formula minus 1 raised to the power n plus 1. So n plus 1 divided by, there are two parts. First part is factorial n. The second part times the quantity 2n plus 1. So the quantity 2 times n plus 1. Then enter. They're exactly the same, except for the first item. So we'll change this. So using an if statement. So that is the quantity if n is equal to 0, then minus 1, just like this. Then enter. Now they're exactly the same. We can continue with the expansion. So it is array formula, series sum of the x values raised to the power 2n plus 1, where 2n plus 1 starts from at n equals 0, 1. So it starts from 1, followed by 2 times 1 plus 1, 3. 2 times 2 plus 1, 5. 1, 3, 5, 7, 9. So the increment is 2. And the coefficient, we'll choose one of the two. So we'll choose the double factorial. You still get the same answer if we use the factorial. And we'll chart this. Insert chart. And we will use scatter chart. Use row 1 as header, column A as label. The series, trend line, polynomial to the 8th degree. Use the equation as label. For the legend, position at the bottom. And horizontal axis, the number format, none. For the vertical axis, show the axis line. That's the axis line. And the number format, none. So here's the trend line and the polynomial, the trend line polynomial of the expansion. Next, we continue with the Gauss function. It's a Gauss negative function, so this is equal to array formula Gauss of x, and enter. We show the trend line. So edit chart, trend line, polynomial to the 8th degree. Use the equation as label. So we now have the polynomials and the trend line. The trend lines. We'll calculate this using the polynomial regression coefficient using LINEST by completing the LINEST matrix. So starting with the power transpose 0 to 8. And the elements of the matrix array formula of the x values raised to the power 0 to 8. Now we can calculate the linear polynomial regression coefficient. So the LINEST polynomial LINEST data y and data x. And these are the polynomial regression coefficients of the expansion. Now the function itself, the Gauss function. LINEST data y and data x. And enter. Next, we modify our Gauss function to match the expansion. So there's a negative sign, so minus x. Then there is a square root of 2. So this is multiplied by, x is multiplied by square root of 2. Next, the Gauss function is multiplied by square root of pi. So times square root of pi. And enter. The data sets are exactly the same. The polynomials are exactly the same. That's the trend line. They're exactly the same. The polynomials are exactly the same. And the polynomial regression coefficients are also the same. Starting with x to the 0, coefficient is 0. Coefficient of x, negative 0.997. Coefficient of x squared, 0. Coefficient of x cubed, 0.313. Coefficient of x to the fourth, 0. Coefficient of x to the fifth, minus 0.0696. Coefficient of x to the 6, 0. Coefficient of x to the 7, 6.54 times 10 to the minus 3. And coefficient of x to the 8, 0. Next, we change because we're using the double factorial. Suppose I change the factorial as the expansion coefficients. This time we'll use the factorial. Enter. The data sets are still the same. The trend lines are still the same. The polynomials are still the same. And the polynomial regression coefficients are still the same. This completes the use of double factorial in generating the expansion of the Gauss negative x function using Taylor-Maclaurin series sum and LINEST polynomial regression.